All right, here's the same problem that we did in the last video. We did it in the last video by recognizing that our integrand here was just the result of using the chain rule to take the derivative of a function composition. And so we sort of pieced together what all the different parts were. I promised that I would show you a notational trick that just makes things a little bit simpler. Okay. So again, we've got here a product of two functions. One piece is a composition, and the inside part is sine of x. Okay. So I'm going to just call that u. I'm going to let u be sine of x. Because what happened is we didn't end up actually having to find an antiderivative of the trig functions here. Because what we had was that we were able to, from looking at the result of chain rule, we were able to figure out sort of what f prime g and g prime were. In order to know our answer, we needed to know what f was. So we needed to find an antiderivative of the function we were plugging sine into, of the square root function. Okay. Now, if my u sub is going to work, I'm going to just note that u prime is cosine of x. Because I'm essentially saying I'm going to write this g of x as u. This is only going to work if I have a u prime hanging out in there. Okay. And what I'm going to do is I'm going to say that du is cosine of x dx. Now, I promise we're going to talk a little bit more about this notation after we've done a few more examples. But it will always be the case that du is just u prime times dx. That's the relationship between these things that we call our differentials. We'll return and talk about the meaning of that when we do an example with a definite integral, because I think it makes a little bit more sense in that context. Okay. All right. So with that, I'm able to rewrite my entire integral now in terms of u. I can say that the cosine x and the dx together form a du, and this is just the square root of u, which if I wanted to, I could rewrite as u to the 1/2. So remember, when we did this problem before, we had figured out that f prime, the function we were plugging sine into, was the square root function. That was the function we needed to find an antiderivative of so that we'd know what f was for our answer. So this really makes it very clear that the function that I need to find an antiderivative for is this square root function, or the 1/2 power. So I'm just rewriting things in terms of u. Notice here I'm saying that cosine x just sort of gets absorbed into the du. So this big integrand sort of collapses into something a little bit smaller because this factor is part of the du. I want to just show you one thing that you're going to see other people do that I don't want you to follow. Okay? I looked, I said, this is what I need. I have it. I'm just going to rename it du. Fabulous. What some people will do sometimes is try to solve for dx. So they'll say dx is du over cosine x, and that is not correct. Okay. The reason is that's a variable. Is cosine of x ever 0? Absolutely. Lots of places. Okay. But I know I cannot divide by 0. So there may be times when I've got dx is being multiplied by something that isn't 0, and I can divide by that to solve for dx. I'm going to suggest that you just never do it. Do not solve for dx. If it involves dividing by variables and that variable quantity could be 0, you are running the risk that you are dividing by 0, which is undefined, and I will dock you points if I catch you doing that. And I warn you about that because lots of people do that. Okay? You can actually get away with it most times. Because, of course, if I did that, I'm just going to cancel it immediately with the cosine x. So it's not going to stay there hanging out on the bottom. It's just a really bad habit because it gets you into the habit of dividing by variables, and that is really going to hurt you when you get into a situation where you want to, but you can't. If you're used to doing it, you're going to do it. Okay? So it usually, if you do that, it will usually still lead to the right answer, but it is incorrect. And there are lots of people who are less picky about this and who let people go ahead and do this. I don't. So you may find tutors, you may find people who've taken this class before, people who are in other classes who solve for dx. Just don't do it. It's not necessary because that's du. All I'm doing is saying, oh, I have a du. Okay. All right. So now I just need to find myself an antiderivative. So I can say, oh, let's use the power rule. That's going to be u to the 3/2 divide by the new power. So that's going to be times 2/3. Don't forget the plus c. Okay. And then I've essentially done what I needed to do here, but the original problem was in the language of x. Now I'm sort of talking in the language of u. Let's translate back to the original variable. So u was just sine of x, so this is 2/3 sine of x to the 3/2 plus c. Same answer we got last time, but the notation made it a whole lot simpler and really allowed us to focus on the fact that that's the function I need to find an antiderivative of. So it works out very, very nicely. We'll do another example of an indefinite integral. Then we'll come back and do a definite integral, talk about a little bit what's different there. And when we do talk about the definite integrals, we will return and talk about why this actually works and what it actually means. It's not just a magic manipulation of symbols. It actually means something. It's kind of cool.